in the previous video, we understood what exactly the data structures and how it get implemented, abstract data structures and all. Also, we covered some parts of algorithms also. So we aware about whenever we have any software related problem, what we normally do, we try to understand the problem and we try to write down the steps in which we will try to solve that particular problem. And that step by step representation of our solution is nothing but a kind of algorithm. Now, how we will decide whether the solution is the best solution or not. So we calculate how efficiently that algorithm fits or works in a different scenarios. If I input this particular thing, then how the algorithm will react and how soon or easily I get the output. So based on that, we calculate the efficiency of algorithm. So we understood that normally in calculating the complexity of algorithm, we try to understand number of steps, number of instructions we have to execute, and accordingly we calculate the complexity. So this two slides we already understood, and there are n number of in a program one there are the different number of instructions are there. In a number program two there are different instructions. Number three there are different instructions. So respectively we calculate their complexity or total frequency count of a program one, two, three. So obviously, if you have a more instructions to execute, you will take so much of time for the program execution. So again, if you have a n number of instructions, you will store n number of data. So there is a again another complexity will raise, and that is nothing but a space complexity. How you allocate the memory, how effectively you use the memory allocations, and how you use data structures over there. So this thing we understood, but one more thing in this particular diagram, you're able to see there is a O of one, what exactly this kind of a notations are. So that thing we will understand today. So whenever you are trying to resolve, whenever you are trying to create any kind of a application, always you have to remember these things. So there are a number of technologies in which you can develop the software. There are a number of ways you try to solve the problems of your software development. But we have to always select the optimal and best suited solutions, and it should have a low time and space complexities. So first of all, let's understand what exactly the design and analysis of algorithm is and how we are going to build it in our uh, software development. So design and analysis of algorithm is a fundamental aspect of a computer science, and that involves creating efficient solutions to the computational problems and evaluating their performances. Now, DSA focuses on designing the algorithm in such a way, in an effective way, and address the specific challenges and analyze their efficiency in the term of a time and space complexity. Now, complexity analysis is nothing but a technique in which categorize time taken by the algorithm with the respective input or input size. Now, this particular analysis is independent of a machine, language, and a compiler. So it is used for the evaluation purpose. We use there are some cases: best case scenario, worst case scenario, average case scenario. So like this, we examine particular algorithm or particular solution on the basis of these three cases, and we calculate the complexity of that particular algorithm. So in here, whenever we are talking about the algorithm, obviously we are not going to create a small algorithm for sorting and searching purpose. We are creating a software, and for that we are writing one solution. That solution we are considering as an algorithm. So consider you have a one product, you decided, you modeled that particular product, how to build it and how you are going to process. So that particular steps also we consider it as an algorithm. So in each and every steps, you have to take care of which will be the best suited solution, which will be the best suited design structures and technologies, and each and every file you are writing, you have to make sure that this is the best way of writing the code. This is the best solution for this particular problem. So in that aspect, we are talking algorithm over here. So it's not a kind of a thing that we are writing one algorithm and no. This is related to your product, to your project. Always try to take care, always try to concern about the best suited solution. So that's why this particular topic is handled first or released first. So you'll understand what exactly the things you have to do when you're creating the application. Now, what is the need of a complexity analysis? Fine. So you're saying that while creating any kind of project or application, take care of these things. But why it is needed? So complexity analysis determines the amount of time and space the resources requires to execute it. So obviously everyone is here. Nowadays we are creating the web applications and response time is really important, as well as we are dealing with a huge amount of data. So space or a memory thing, taking care of a memory management is also important. So for that thing, this analysis is important. Now it is used for the comparing different algorithms on different input sizes. So we are doing the analysis on the best case, worst case, and average case scenario, as I mentioned you before. Complexity helps to determine the difficulty of a problem and often measures by how much time and space it takes to solve the particular problem. So time complexity mainly depends on the many parameters. We can say as a computer, infrastructure, then the compiler and all. But here we are only dealing with the size of input and uh, the frequency of your data or frequency of the input. Now, in by taking care of that particular way, by dealing with only the size of the input instances or the frequencies of the input instances, we have some kind of an analysis. We divided that analysis into three categories: worst, average, and best case analysis. The main idea of asymptotic analysis is to have a measure of the efficiency of a algorithm, and that don't depend on the machine specific contents or constants, and it doesn't require the algorithm to be implemented and time taken by the programs to be compared. Now there are mainly three symptotic notations. First one is a big O, then omega notation, and then there is a theta notation. So let's understand, theta notation is also called as a average case complexity algorithm. So theta notation encloses the function from above and below. Since it represents the upper and lower bound of a required time of an algorithm, it is used for the analysis of an average case complexity algorithm. Now, theta is normally, we mention it as an average case. So you add the running times for each possible input combinations and take the average. And this is the average case scenario. So for average case scenario, we normally use the theta notation. Now, average and best case scenario, we don't have to take care of, right? And obviously, if your algorithm is meeting that condition, well, and it is really good. But always we have to take care about the worst case scenarios, right? So for the best case scenario, obviously your system will work, your product will execute, but in a way, worst case scenario also it should work. And that represents by means of a big O notation. So big O notation represents the upper bound of the running time of an algorithm. So therefore it gives you the worst case scenario complexity. And this is most widely used notation for asymptotic analysis. So when we observe now the previous slide, all the complexity we mentioned over here in the form of a O notation, right? So why? Because big O notation represents the worst case scenario. Best case and average scenario, we don't have to take care of that thing so much, but we have to take care of the things which are nothing but a worst case scenarios. And consider you want to delete something in an array, and that particular thing is available at the last position. So you have to visit first, second, third, fourth, fifth, sixth, and then you will get the last, and then the match found, and then you are going to delete particular thing or searching thing. So like this is the worst case scenario of your algorithm. So worst case scenario is identified by means of a big O notation, and it's most widely used notation for asymptotic analysis, and it specifies the upper bound of your function, the maximum time required by the algorithm, or a worst case time complexity, and it returns the highest possible output value for a given input. So big O, it is defined as a condition that allows the algorithm to complete the statement execution in a longest amount of time possible. And omega is nothing but a best case scenario. So omega notation represents the lower bound of the running time of algorithm. Thus, it provides the best case complexity for an algorithm. So the execution time serves as the lower bound on the algorithm time complexity. So I hope that big O omega notation and theta notation is little bit clear to you. And you will implement these things when you are developing any kind of a product. Now let's go ahead with the data structures again. So we introduced the data structure, then we introduced the algorithm and time and space complexity. Then we are slightly moving towards the classification of a data structures, abstract data structures. And then we will slowly move towards the ASP.NET collections and how these data structures get implemented in the ASP.NET, and how effectively and efficiently you use these kind of data structures, and what will be the best scenarios and when to use what. So these things we will discuss further. Now let's go ahead with the classification of a data structure. So data structures, obviously we discussed this particular diagram before. Linear and non-linear. Linear again divided into static and dynamic as per the size get increased array, and then dynamic is a list, stack, queue. Non-linear obviously graph and tree. So these are the abstract data structures available in the ASP.NET, as you can see. Again, see, the data structures are divided into the groups on the basis of different scenarios. Okay. Now here data structure is primary data, primitive and non-primitive data structure. Again, non-primitive data structure divided into linear and non-linear. Like this also you can classify. Again, static and dynamic. So vice versa, you can do it. Now the classification of a data structure. There are different kinds of a data structures, and they are classified as based on a different categories. Okay. So data structures can be classified based on a various characteristics, including their organizations, relationship among elements, and the nature of their operations. Here are some common classification. Based on a memory organization, obviously primitive data structures and non-primitive. Primitive data structures are nothing but a primitive data types like integer, floats, characteristics, and booleans. Non-primitive, obviously our classes and lists and linked list, stacks, queue, trees, and graphs. Based on a relationship among the elements, there are linear and non-linear. So you can go ahead through the slides and understand. Based on accessibility, static and dynamic, size and structures are fixed in case of a static data structures, and dynamic we can increase as per the data inserted or available in the dynamic data structures. Based on a uses and operation, primitive and data composite. So you can go ahead with the next slide. Next, based on a storage allocation, continuous and linked data structure. Continuous is obviously the memory allocation is adjacent. An example is obviously array. And linked data structures, which are data structures created by using the linked list, where is the insertion and deletion is by means of that node. And it is available in example includes lists, trees, and graphs. Based on implementation, now here it is. Arrays, linked list, stack, queue, trees, graphs, and hash tables. So there are some common data structures and their algorithm complexities for the access. It means fetching the data, search, insertion, deletion. Then again, worst case scenarios, average case scenarios are there. So you can go ahead with this thing and decide in which scenario what you want to do. If you are doing insertion, deletion, then which data structure is feasible and beneficial for you, use it. There are various advantages of different data, using different data structures. Don't go ahead only with the list. And because most of the projects, most of the applications are only using the list, you can try with another data structures and verify the differences. So this is all about the classification of data structures, little bit algorithm, its complexity and analysis. And next we will start with the arrays, lists, and then stack queue, and then there are the collections and so on. So let's stop here for today for this particular video. Let's go ahead with the arrays in the next.